Greetings everyone, this is Shep with the latest update on the GPS clock project. First, to show you a few of the components here. Nothing but a AC jack, spacer here, and then on top we have the display, GPS unit, a couple buttons here, and the Arduino that powers it. So once it goes into this enclosure here, you can plug it in, no fancy battery tricks or nothing. Let's just power it outside of here for now. And plug it in, and as it gets the signal, it powers up, and there you can see 6:59, which is not the correct time yet. I have got to get a code change in this one to sync it up properly, but in a few minutes it will sync up. And then daylight savings time off, or we can turn it on with settings here. Time zone -5, which is Eastern. Brightness level 4, it gets a lot brighter than this. You can set it all the way up to 16, which is ridiculously bright. You can see the glow in my fingers here. And go to 1, and it's almost nothing again. I like to set it to 4 for nighttime use, but it's very bright. Hour type 12 or 24, and then 7:49 syncs up. So it doesn't take that long to sync up, believe it or not. It only takes about a few seconds at most. But it always is very consistent with the multi-million-dollar satellites that we use for GPS. So top.am, bottom.pm, and to show you a bit of what it can do here, let's hit daylight savings time on, and leave all the other settings alone. Now it's 8:49. Daylight savings off, and it's back to 7:49. Time zone -5. Let's set it to UTC time, and then boom. 12:49, which is the current time in UTC, and you can set it to, let's say, +5. Now it's 5:49 p.m., which is the correct time. Go here, flip it all the way to +12 or -12, and then it loops over to -5. And let's set the hour type to 24 hour. Now, because AM, it's going to show 7:50. It's not going to show anything useful here. So that's why we should then set it to, let's say for example, +7. And then set it here, and I get 1950. And just to show you guys that it does work well, we'll go +10 here, 2250. And then +12, 050. Instead of 2450, it shows 050, which is correct here. So that's good to see. And set it back to the settings I kind of like to have, and bada bang. So that's the GPS clock in a nutshell. And the neat thing is, right now, it fits in an Altoids tin. So when you unplug it here, you actually fit it, and it just snaps right in. If I can get this latch to snap in, there we go. And then plug it in. After it boots up, you can see the red light flashing on the Arduino here. Then it boots up. For some reason it keeps default at 6:59. I've yet to figure that out, but that's a code change, that's not a hardware change. So once that gets squared away, it'll then sync up the correct time. For now, I'll just leave it going so you can, there it goes. So you can see it sync up, 7:51. And I don't have a watch handy, but I do have a computer here. So I'll bring you guys over to see it. You can see my computer clearly says 7:51 a.m., which is the same thing that this clock is saying. That's it. No real-time clock circuitry. Nothing else except a GPS, display, and Arduino, and power, of course. Alright, that was the latest update for a GPS clock. Shep out.